Okay, 8th graders, we're getting to the end of our Systems of Equations unit. Today we're going to talk about the 3 different methods you've used to solve these equations and why you choose which one and when is the best time to use it. So it's important to be able to look at the system before you start solving it and decide which method is going to make this problem easier for me, because you guys don't ever want to do any more work than you have to. So when would we use graphing? We would graph it when it's in an easy form for us to graph. So when the y is isolated, especially if we see fractions. We don't want to have to do any math with these fractions. If we can just graph this with a slope, we're going to do this. Now, it'd be different if these numbers were ginormous, but these numbers are all nice and easy ones for us to graph. So if you'll see systems like this, the quickest way to do this is going to be to graph them. So when would we use substitution? You're going to want to use substitution when one or both of the equations have a variable that is isolated. And isolated means by themselves, okay? So if you look at these different systems, well, if we have x by itself there, we can just plug it right in. If we have y by itself here, we can just plug it right in. So just to kind of give you an idea, I'll just do some circling like this. We would put this right in for y, and then this one, we'd put this in for x right there. Okay, so when you've got that variable that's isolated, that's when you would use substitution. So when do you use elimination? You use elimination when basically the terms are lined up, when they are in standard form. So when the like terms are lined up, I'm going to say. So for example, the x's, the y's, those types of things. Even more so when we have, like a negative 5y, positive 5y, because right away then those cancel out and it makes your life a little bit easier. Okay, so let's decide. We're not going to solve these. We are just going to decide which method would be best. Okay, so for example, I look at the first one. I have one of the y's by itself, so I would use substitution. The next one, I have my terms lined up, neither one of the variables by itself. I would use elimination. Let's take this one step further. What would I multiply by? I would probably multiply this bottom equation to get to, if I just had to multiply this by a -2, because, and you can have the -2 here, or over on this side, I just don't have very much room. The reason is because if we multiply by a -2, then this would become a -4, and that would cancel that one out. Okay, so this one, both of the variables by itself, and you could either set them equal to each other and use substitution, or because they're both in slope-intercept form, graphing would also work, providing you had graph paper. Sometimes solving it algebraically works just as fast as graphing. The next one, because I have this fraction, I would probably go with graphing. The next one, I have this x by itself. This is in standard form. This isn't in a nice form at all, so I would definitely use substitution. And then the last one, my terms are lined up. I would probably multiply. You could either multiply by a 5 and a 2 or a 7 and a 3. You could get these to 21 is probably what I would do to get them to match. So I would use elimination. The one thing that I need to make clear is that just because I used elimination doesn't mean you can't use substitution. Or it doesn't mean you can't graph these. Just because I would graph this doesn't mean that you couldn't use substitution. So sometimes it's just easier to use one method over another, but there's no law that says you have to do one or the other. The other thing is you could do it all 3 ways to make sure you get the right answer. So if you were really questioning things, you could solve it every way. Okay, so now we've got, 5 problems here. It says let's choose the best method to solve and only use a graph if needed. And let's actually solve it. So this first one here, I think that I would use substitution because I've got the variable by itself. So I'm going to write substitution. And I'm going to put this in for my y. So I have 4x minus 3 times 3x minus 4, and then equals 7. 4x minus 9x plus, remember this turns to a plus because it's negative 3 and negative 4, plus 12 equals 7. 4x minus 9x, negative 5x. Move this 12 over to the other side by subtraction. This gives you negative 5. I divide both sides by negative 5. You get x equals 1. So we know our x is 1. I'm going to put that back into that original equation. Y equals 3 times 1 minus 4. X equals 3 minus 4. Or sorry, y equals negative 1. Okay, so there's our solution. We don't have to graph it. The next method, because I've got this 1/3 in here, I would probably graph it. They are smaller numbers. You might want to just rewrite this. Y equals 1/3 x plus 4. Some of you visually, that might be helpful. So I'm going to go up to 4. 1, 2, 3, 4. My slope is 1/3. Down 1 over 3. Sorry, I graphed that bottom line first. You want to make sure that you have a nice straight line for these. Okay, and then I'm going to graph that other one. I start at negative 3. 1, 2, 3. And my slope is a negative 2. So down 2 over 1, or up 2, left 1, up 2, left 1, up 2, left 1. Sometimes I like to just follow my slope up until I see exactly where they cross. So our solution here would be 1, 2, 3, negative 3, and then up 1, 2, 3. Okay. Okay, on the next one, what method? Well, they are lined up, so I would use elimination. Okay, and let's see, what do they have in common? Well, 6 and 8 both go into 24. 5 and 8 both go into 40, so you could go either one. Looks like we're going to have to multiply both equations. So I'm going to multiply this one by, just to try to keep my numbers a little bit smaller, I'm going to go to 24. So I'm going to multiply this one by a 4 and this one by a negative 3. Doesn't matter which one you make negative. So my two equations, one would be 24x minus 20y equals 4 times 8 is 32. My bottom equation is going to be negative 24x plus, because I have a negative and a negative, 8 times 3 is 24, and then equals negative 24. Okay, when I combine these cancel. I get a positive 4y equals 32 minus 24 gives us 8. Divide both by 4s, y equals 2. Okay, so there's our y. Now we have to find our x. We're going to do so by putting it into one of the original equations. Does not matter which one. I'm going to put my 2 in. So 6x minus 10 equals 8. Add 10 to both sides. 6x equals 18. Divide by 6, divide by 6. X equals 3. So my solution is 3 2. Okay, so we're going to do the next problem, but we're going to solve it in 2 different ways. So, for example, let's do the first way, doing elimination. It's set up. That's technically what most of you would probably pick. Okay, so let's try it that way. Right away, my 4's would cancel. And these would cancel out, and I'd get 6x equals 16, and 8 would be 24. Divide both by 6. X equals 4. Okay. And then I would put that back into my original equation. I'll do the bottom one just because I have positive numbers. So I'd have 12 plus 4y equals 8. Minus 12 minus 12, 4y equals negative 4. Divide both sides by 4, y equals negative 1. So my solution is 4, negative 1. Now let's just graph this, since we know that visually we can see then what the solution is. Like I said, we've got the both equations. We just have to get y by itself in both of them. 3x minus 4y equals 16. First thing I'd move is that 3x to the other side. Negative 4y equals, and I write that already in the right form. I'm going to run out of room here. Okay, there's the first one. I'm going to do the other one. Okay, 3x plus 4y equals 8, minus 3x minus 3x, 4y equals negative 3x, plus 8, divide by 4, and I get y equals negative 3/4 x plus 2. So, then I'll graph these really quick. Positive 2, down 3, 1, 2, 3 over 4. 1, 4. Here's my first one. And then my other one, I'm going to start at negative 4. 2, 3, 4, and it's positive 3. 1, 2, 3 over 4. You guys can see right then and there where they meet. So, does our answer match? And it does. It is 4, negative 1. So that's a way. It doesn't matter which methods you choose, you are going to get the same solution. So that's all the notes I have for you today. What you guys are going to do is you are going to finish the worksheet here, and I believe I have an iExcel for you. Okay, I hope you guys are doing great. Make sure to send me any of your questions and we'll go from there.